Okay, so we're going to continue with chapter 2, section 2.2. After going over functions in general, I'm going to talk about graphs of a function. And we know to graph any function, we need to make a t-chart. And of course, we have a graphing calculator that's required, so we can check our work with the grapher. We can also check the t-table. We can do a lot with the graphing calculator. Page 167, number 12. How do we graph g of x equals x squared plus 2x plus 1? And if we make t-chart, usually we pick a couple of negatives. And 0, 1, and 2, if we plug it in there, we get negative 3. Negative 1 squared plus 2 times negative 1 plus 1 is 0. That's a 1, that's a 4, and that's a 9. See, to get your t-chart, you can also use your grapher to do that. So you can key in the equation. Let me zoom in. Okay. So y equals x squared plus 2x plus 1. And then this you go to second table set. You want to do auto on the x variable. Second table, and then it will generate, you can go up and down. You can see as many x and y values as you want. And then of course the graph, to check your graph. I don't know why it's not showing a good picture. Let's see if we can zoom. No, let's zoom again. Okay. All right, so this is, so you're gonna do a t-table by hand, and then you're going to check it with the grapher. Make sure you're familiar with the grapher, because graphing calculator is required in this class. Okay. Okay. Here's another example. Okay, they want domain and range. So if you graph it, here. Once you graph it, then you can easily do domain and range. So -2, -3, -1, 0, 0, 1, and 1, 4. And then and then 2, 9. It's gonna go up to there. -2, it's a 4 plus 2 times -2. Oh, -2, 1. That's wrong. This should be 1. Okay. So it should be plus 1. Let's fix that. So make sure you fix the one in the notes, number 12, page 167. It should be -1. I had -2, -3 by mistake. So when you graph it, it looks like this. And then you can see domain is your x values from -infinity to +infinity. And range is the y values. There's no y, the graph below 0, so it's from 0 all the way to infinity, including 0, because 0 is a y value, like -1, 0. Okay, here's another example, 22, page 167. Again, c of t equals -1 over t plus 1. They want us to graph. And then find domain and range. If you do -1, it's undefined. I picked that intentionally because -1 over 0 is undefined. -2 is 1. -3 is 1/2. 0 is -1. 1 is negative 1/2, and 2 negative 1/3. Make sure you know how to get all these values. So it's undefined at negative 1. Okay, so that means we have what we call a vertical asymptote there, or t equal negative 1. That's t, that's y, or c of t. At negative 2, it's 1. At negative 3, it's 1/2. At 0, it's negative 1. At 1, it's negative 1/2. At 2, it's negative 1/3. So we see a pattern, and is it gonna cross the x-axis? Does that mean y equals 0? This is never gonna equal 0, so it's gonna go up there, and over here, same thing. It never ever crosses a vertical asymptote, and it's not gonna cross the x-axis, because if you put a 0 here, it's not possible. So you can see the domain is all real numbers except negative 1. So negative infinity to negative 1 union negative 1 to infinity, that's domain. And then range, you can see the range, all real numbers except 0. So negative infinity to 0 union 0 to infinity. Okay. Now, if we're given a set of ordered pairs, how do we know this is the function representation? So for instance, if you have f equals 1, 0, 2, and 3, 1. Okay. So we talked about function. What a function is, it's a set of ordered pairs, or a rule whereby no x value is cheating. No x value is repeated with 2 or more y values. So if any x value repeats, then it's not a function. It's just a mapping or a relation. Okay, so you can see 1 is paired with 0 and 1 is paired with 2, so it's not a function. And again, when you're given a set of ordered pairs, if you see any x value paired with more than one y value, then that's not a function. A y value may be paired with no x value, 1 or a million x values, and it would still be a function. It's a double standard relationship. So no x value can be paired with more than one y value. Now, what if we're given equation? How do we identify a function from its equation? Identifying a function given its equation. Make a t-chart. If you want to graph it, you want to make a t-chart, and then no value can be paired with more than one y value. So you can just bring that down here. So for example, 62, page 168, 2x squared minus 4y squared equals 3. Is this the equation of a function? Well, let's see. If we pick any x value, say x equal 2. We put in, and then we get 2 times 4 minus 4y squared equals 3. 8 minus 4y squared equals 3. 5 equals 4y squared. 5 over 4 equals y squared. So for each x value, you're getting 2 y values. That's not a function. Okay, x is paired, 2 is paired with root 5 over 2, and 2 is paired with negative root 5, 2. I got 2 because square root of 4 is 2. That's where the 2 came from. So this is definitely a non-function. Okay. And if you look at y equals square root of x, no matter which x you plug in, you're getting a 1 value. 9, 3, 5, root 5, so on. So it is a function. Now, what if we're given the graph? How do we know it's the graph of a function? So identifying a function given its graph, we use what we call the vertical line test. Use the vertical line test, which says no vertical line should cross the graph of a function more than once. if any vertical line crosses the graph of a function more than once, then it's not a function, for instance. And let's see why. Like if you have this, if you draw a vertical line here, x is paired with y1 and y2. Remember, we cannot have that. Same x is paired with two different y values, that's not a function. So if any vertical line crosses the graph of a function more than once, then it's not a function, it's just a relation. Okay. If you look at 54, page 168, if you look at 54 page, you can see an ellipse is not a function. You can look at the graph there, let's roughly sketch it. It's obviously not a function because the vertical line here crosses the graph twice. So it's just a relation, it's a non-function. All right, how do we graph a piecewise defined function? So to graph a piecewise defined function, we want to graph each piece, because it's multiple pieces, each piece using a t-chart. From that piece's domain. And of course you can check with the grapher, but you need to know how to do it by hand as well. For example, number 38, page 167. So how do we graph f of x equals 2x plus 3 if x is less than -1, and 3 minus x if x is greater or equal to -1. So the first piece is right there. Y or f of x equals x plus 3, but remember the domain, you can only pick values from that piece, from that domain. So less than -1, we can do -2, -3, -4. We cannot do 0 here, or 1 or 2. Put a -2, 2 times -2 is -4 plus 3 is -1. -6 plus 3 is -3, and -8 plus 3 is -5. And -2, -1, -3, -3, -4, -5. So you can see it's a line that's going to extend in this direction. I'm a little sloppy, but it's going to reach -1, but not including -1, because x is less than -1. So at -1, it's going to go to this equation, and that's what the second equation is for. So y equals 3 minus x if x is greater or equal to -1. So we can pick -1 in this piece and plug it in. 3 minus -1 is 4. We can pick 0. 3 minus 0, 1. 3 minus 1 is 2. And it's a line, so that's enough. So -1, so instead of being -1, 0, it's -1, 4. It jumps to 4. So it's closed. And then 0, 3. And then 1, 2. And you can see it's going to extend indefinitely in this direction. And we can actually, if you don't know how to do it on the grapher, I'll show you. So let's zoom this. Okay, so you go to y equal, and now we want to do the first piece, which is 2x plus 3 should be in parentheses because we have to do condition. So we do left parentheses, 2x plus 3, right parentheses. Now this calculator doesn't have a keyboard to type F, but you see the division sign right here. That's going to mean F if you do division sign. And then the condition is x is less than -1, again in parentheses. So you do left parentheses, x to get less than, you're going to do second math. We'll take you to test second math. And less than is number 5, -1, and then right parentheses. And then you go down to y2, same thing. It's 3 minus x if, again, x is greater or equal, so second math to take us to test, greater or equal is number 4, -1, right parentheses, and there we go. Now the calculator is not gonna give you open circle, closed circle. You have to figure that out, okay? So hopefully that helps. So now we can look at number 46, page 168, which is 3 pieces. 46, no, sorry, let me go back to zooming in or zooming out. Page 168, how do we graph f of x equals negative x if x is less or equal to 0, 9 minus x squared if x is between 0 and 3, not including 0 but including 3, and x minus 3 if x is greater than 3. So we're going to do one piece at a time, and I showed you how to check it on the grapher, so you can do that. Next, okay, so x is 0 or less. We can start with 0, negative 0 is 0, then we can do negative 1, it will be the opposite of that, negative 2, the opposite of that is 2. I'm going to do the graph on a clean sheet of paper because I need space. Okay, so 0, 0, negative 1, 1, negative 2, 2, and it's going to extend indefinitely in that direction. And you can see I have a closed circle at 0, 0 because that includes 0. Okay, 0, 0 is a point on this part. Then the second one, f of x is 9 minus x squared if x is greater than 0, not including 0, and less equal to 3. So we cannot pick 0 here, we can pick 1. 9 minus 1 is 8, pick 2. 9 minus 4 is 5, we can pick 3. 9 minus 9 is 0. So 1, 8. 2, 3, 4, 5, 6, 7, 8. 2, 5, 2, 1, 2, 3, 4, 5. And then 3, 0. So you can see it's a parabola. It's this piece of the parabola. It's a closed circle here. Now at 0, it's not included. So if 0 was included, it would have been 9. So the graph would have been like this. But it's an open circle there because at 0, it's going to be 0, not 9. Okay. And then the third piece, f of x equals x minus 3 if x is greater than 3. So we can pick anything greater than 3. 4 is 1, 5 minus 3 is 2, 6 minus 3 is 3. That's more than enough to graph a line. So 4, 1, 5, 2, and then 6, 3. It's a line. And that line, if 3 was included, it would have been 0, so that's good. That means it would have been open here, but it's closed by the previous one. And that's the graph. One more thing from this section before we call it off is the greatest integer function. The greatest integer function. Okay, first let's define the greatest integer in x, then we'll talk about the function. The greatest integer in x is defined as the largest integer that is less or equal to x. Less or equal to x. So, you know, phone companies, they used to be, when they used to charge by the minute, if you talk for 1 minute and 1 second, they would go up. So 1 minute and 1 second, they would charge you 2 minutes. So it's not the greatest integer. They used to do ceiling. The greatest integer is also called the floor. So the greatest integer, the notation for that, there's integer of x, and there's this notation. These both mean the greatest integer. Okay, if you say greatest of 1.1, it takes you to the floor, so it takes you to the left. the greatest integer of 1.2 is 1, and so on. Greatest integer of 1.999 is 1. Once you reach 2, then it gives you 2, because it's less or equal to x. If x is an integer, it gives you the same answer. Now we gotta be careful with the negatives. So say you want to do a greatest integer of negative 1.5. It doesn't give you a negative 1. Remember, you always go to the left. It's negative 2. And your calculator actually has a t built in. So you go to math. You go to math, and then number. Go to number. Scroll over one space right. And then number 5 is the integer. So you say you want to do the integer of negative 2.5. It gives you negative 3. Okay, so you can check that out. Now to graph the greatest integer function, so when does it become a function? When you make it equal f of x or y. To graph it, you can put that into your grapher. Okay, I saw you how to retrieve this. So you go math, numbers, number 5 of x, and then graph, and it's a step function. All right, that's it for 2.2. So let's